Ali Ghodsi.
Hello, everyone. Super excited to be here. We actually have now online 75,000 people worldwide that are actually listening in to this live stream.
Lakehouse IQ is just like a dream to me, just because of all the capabilities it has.
Amazing to learn about the implementation of LLM models.
I like the direction which Databricks is going in, and we're looking forward to it.
Unity Catalog has been really important to us. Lakehouse Federation and monitoring, yeah, they make it even better.
Everybody's just geeking out and having fun with data.
It's not about educating yourself on what you're doing today. It's about where the world is going.
Please welcome to the stage, Director of Machine Learning, Brooke Wenig.
Good morning to everyone joining us here in person, and good morning, good afternoon, and good evening to those of you joining us here virtually. Now, I know it's early in the morning, but please make some noise if you're enjoying Data and AI Summit. Woo! That was so good, I'm not going to make you do that again. Data and AI Summit is truly the highlight event of the year. I love that it connects data teams from around the globe and truly builds a community. I first attended what was then known as Spark Summit in 2016. And a few years later, I was on this very stage demoing the latest features of Apache Spark 3.0. I'm thrilled to be here with all of you today. As a bit of housekeeping, the keynotes will run until 11 a.m. There are no scheduled breaks, but if you do need to get up, we ask that you be respectful of our presenters and those around you, and to do so in between sessions. Before we can get into the keynotes, I want to thank our partners. Without them, this event truly would not be possible. Please put your hands together to thank our partners. And I want to do a special shout out to Accenture, Avanade, AWS, Microsoft, and Prophecy. Please visit them in the expo hall after the keynotes. To kick off Data and AI Summit, we launched the So You Think You Can Hack hackathon. It focused on either building LLM-powered applications or leveraging Spark Connect. And we had both an in-person and a virtual track. And over 800 participants participated in this hackathon. So without further ado, I want to congratulate all of the finalists you see up on the slide here. In particular, I want to do a special shout out to the grand prize winners in each category. Schema Spy, who built a system to navigate database schemas with AI assistance. And in the virtual category, Data DM, who built a data assistant to help you load, transform, visualize your data, all without a single line of code, and they actually open sourced it. Please congratulate all the finalists that you see here. Now on to the keynotes. Our mission is to democratize data and AI. But that mission is not that of Databricks alone. It is a shared mission in the data and AI community. And our keynote lineup today reflects that shared mission. Only at Data and AI Summit will you hear from the creators of the hottest open source projects, visionary academics, and Silicon Valley legends. You will not want to leave the keynotes early. We will be closing the keynotes with a fireside chat with Ali Ghodsi and Eric Schmidt, former CEO of Google. I hope you all are as excited as I am to be here today. Woo! As Ali mentioned in his keynote yesterday, technology innovations don't become revolutions until they're truly democratized. Marc Andreessen is no stranger to this. Through creating the Mosaic and Netscape web browsers, Marc truly democratized the internet. something that all of us rely on for our day-to-day lives. 12 years ago, he coined the term software is eating the world, and a few weeks ago, he published a bullish opinion on why he thinks AI will save the world. Without further ado, please join me in welcoming Marc Andreessen and Ghodsi to the stage.
Awesome. Thanks so much, Marc. Thanks for doing this.
Good
Really
morning.
excited.
Good morning, everybody.
Can we get a hands up for those of you who've read his essay on why AI is saving the world? All right. Yeah, there's quite a few people. Maybe we can start. Actually, I'm curious. So you started the first web browser, Mosaic, and we acquired Mosaic ML yesterday.
Yes.
What do you think about that?
You know, if the name is going to get reused, it should get reused for this. So I'm excited.
Awesome, awesome. So maybe starting with that. Actually, I'm kind of curious. So, you know, you've been part of many, many internet revolutions. You've seen it. You've had like the inside, you know, scoop. First the browser, the internet, then social networking. Actually, I don't know if everyone knows this, but you were on the board of Facebook since
2007.
2007. So you saw this whole thing go from like just a place where you check out friends to, you know, this thing that it is today, and now AI is happening. So why did you write this article?
Yeah, well, so AI is one of these things. AI has been around, right, conceptually for a long time, right? One of the interesting things I find interesting about it is it was actually invented as an idea back in the 1930s and 1940s. And so there's been basically this 80-year arc of thinking. And in fact, the original neural network paper that ChatGPT and all these other systems are based on was written in 1943, right? So this has been like an 80-year journey. And AI has kind of been alongside the computer industry and the internet, the entire time. And some companies have figured out certain things to do, but it's never been the kind of main thing in the industry. And then, of course, there's been this huge breakthrough in the last 5 years where all of a sudden it started to work. And so it feels like the moment has arrived. And maybe there's a lot of interesting things to talk about, but one of the most interesting things is why is it happening now? And that goes, a lot to the topic of this conference. Is a lot of why it's happening now is because of data. It turned out one of the things you need to make AI work is just an enormous amount of data. And so it actually turned out we had to get the internet to scale, right? We had to get like the full corpus of the World Wide Web and basically the full crawl that goes into the search engines, and we had to get all the image data on Google Images and videos and so forth. To be able to train these things, and then it turns out they actually work. And then, of course, that means to make AI work even better now means we need to feed it a lot more data. And so it feels like these worlds of like internet, data, and AI are kind of all slamming together. And now magic is happening.
That's amazing. Actually, you had this argument that I read somewhere, which is kind of interesting, is that the previous kind of generation of things feed the next generation. Well, can you explain that? You said books reappear and.
Oh, yeah. So there's this interesting thing. So Marshall McLuhan was this famous media theorist 40, 50 years ago, and he had this thing. He said, each medium becomes the content for the next medium. And so he said basically when like radio emerges, basically what were they doing? They were basically like reading out newspaper articles. When television emerged, what do? They basically televised presentations of stage plays. When the internet emerged, what did it do? All of a sudden it's a platform for all previous media forms, right? Including all of TV and movies and everything else. And then AI is kind of the ultimate example of that, which is then all of these different forms of media basically surge in and become components of training AI. Right. One of the big breakthroughs in AI right now is this idea of multimodal AI. Right. So you basically like if you use ChatGPT today, it's trained on text. If you use Midjourney, it's trained on images. But the new AIs that are going to come out are going to be ones that are trained on multiple media types all at the same time. Right, so you have AI that's trained on text and images and video, right, and structured data and documents and mathematical equations and so forth, and then the AIs will be able to span across all those. And so they all basically roll forward, and it turns out they're all important.
So then, taking this analogy to the next level, what's going to happen next? All these AIs are going to feed the next thing that comes, isn't it?
Yeah. Well, bigger AI.
Yeah, bigger AI.
Bigger and better AI. Well, as you know, like a lot of research in AI right now is basically, so today you train AI with human-created data, and then you have humans do what's called reinforcement learning, where they're basically, the humans are basically tuning the result from the AI. But a lot of the research happening right now is on how to get AIs to basically teach and train each other, right? And so there's going to be this like laddering, this sort of upward cascade where the AIs are going to actually, they're going to train their successors.
So if we get into that then, okay, so it's fascinating. This is going to feed the next thing. So the output of these AIs will train the next AI. And actually, if their output can feed the next one, it seems you now get into this recursive loop, which could potentially happen pretty fast. Yeah. That gets into the whole, the whole doomsday scenario, takeoff, so on. You said it's a category error.
Yeah.
Can you explain that a little bit?
Well, so what happens is there's a sort of idea, and it's sort of a recurring idea in human history. There's sort of this idea that you're going to have something sort of fundamental change in the human experience, and then it's going to lead either to utopia, right, on Earth, right? And the utopia version of AI, right, is this concept called the singularity. Right, and this is this concept originally invented by this guy Vernor Vinge, great science fiction writer in the 70s, and then Ray Kurzweil has carried this idea forward for the last 30 years or so. Right, and so the singularity is the idea that basically at some point computers get basically more sophisticated than human brains, and then all of a sudden you get the singularity, and all of a sudden everything changes and becomes wonderful. Corresponding, of course, to the idea of creating utopia on Earth, there's also the other idea, which is creating dystopia, right? Creating hell on Earth, where everything just like goes completely to crap. And so. The problem I have, I'm an engineer by background, and so these sort of very rapidly to me start sounding like science fiction scenarios. So I don't think this is actually what happens. There's this guy who I like is writing a lot, and he up in Berkeley, and he has this term he calls what we're doing as a species, basically a civilization, he calls we're slouching towards utopia, right? And I like that term a lot, which is like basically it's like things are getting better on the margin, kind of all the time. Like material welfare and health and intelligence and all these things are kind of the capabilities of what people can do are kind of getting better all the time, but they're not getting better in a way that leads to basically an actual literal utopia. But but we're slouching towards utopia. Like in our imperfect and broken and fallen way, right? We do still manage somewhat to improve the world over time. So it's sort of I would say a cautious form of optimism, not the radical form.
Makes sense. So what about the people that then say there's this thing called, I think, instrumental convergence, right. Which actually, can you explain it? So there's this concept of the AI, no matter what goal you have in life, eventually you will converge on some sort of things that you need to do. For instance, gathering energy is important because otherwise you couldn't get towards your goal, or survival is important, and so on. So then eventually these AIs will realize, if they become really, really smart, that they might not be aligned with our interests.
Yeah, so there's a whole. I mean, this gets very deep. So we're going to spend the rest of the day here discussing this. Is that right? This is the next 8 hours.
That's one question on it.
I hope people brought their water bottles because we're going to settle in for the next 8 hours just on this topic. So.
Marc told me before we got on stage, like, if I don't like one of your questions, I'm just going to leave.
I'm just going to like stomp right off stage. There's sort of these two lines of argument. One is like the AI is going to like declare itself its own goals. It's like a Terminator scenario where it's going to wake up one day and decide it hates us. Yeah. And my answer to that is like there's no it. Like they don't. It's not a person. Like it doesn't have consciousness. It doesn't have like a will. It doesn't have any of these things. And then they have this other argument, the sort of so-called AI doomers projecting sort of this dystopia. This other view of like, well, it actually doesn't need to ever have consciousness or sentience or any sort of will of its own. It's just going to somehow like it's basically going to like they're going to like hyper optimize for these small goals.
Paperclip.
So this famous paperclip optimizer, like somebody will make the mistake of telling an AI to like make paperclips, and it will basically decide that it needs to convert all atoms on Earth to paperclips, right? Including it needs to like harvest all human bodies and turn out atoms into paperclips. And in so doing, in order to like maximize the number of paperclips in the world, it will develop its own energies. It'll figure out how to develop nuclear fusion, and it'll have like its own space stations, and it'll have like its own robot armies. It'll have whatever it needs to like maximize the number of paperclips. And it's just like, I don't know, okay, is the problem that it has its own will or that it doesn't have its own will, right? And so I kind of trip it up there. And then there's just like practical limitations, right? And so like a practical limitation is, okay, where's it going to get the chips to run the sophisticated algorithms to make all the paperclips? Because like sitting here today, we can't even get chips to like run AI at our startups. So I have these like fantasies that there's like a baby evil AI, probably running in the lab at Databricks right now with the Mosaic acquisition. It's this like evil baby AI that like wants to take over the world, but like literally it's sent its purchase order to NVIDIA, and like literally it's just not getting the chips to be able to do it. So I don't know. I think we should wait to see. I think we should wait to see the first evil baby AI before we get too concerned about the big ones.
Okay, so let's flip it over. So you said it will save the world, right? And you listed a whole number of things that it has the potential to make better.
Yeah.
Which one is your favorite? And can you walk us through some of those that you're the most excited about?
So the reason to be very positive on AI is because it's in this concept of intelligence. Intelligence is one of these things. It's a very, very interesting topic in and of itself, but we actually know a lot about intelligence because we know a lot about human intelligence. And human intelligence has been the biggest topic of study in the social scientists for the last century. And there have been many thousands of research studies done on the implications of having higher levels of intelligence in people. And it turns out, basically, when it comes to human beings, intelligence makes everything better, right? And that's a very big statement, but it turns out there's like a ton of research to support it. So intelligence basically means that people are going to be more people with higher intelligence are more successful academically. They have more successful careers. Their children are more successful. They're healthier. They live longer. They are also less violent. They're better able to deal with conflict. They are better able to solve tricky problems. They're also, by the way, less biased, less bigoted. They're more open-minded. They're more open to new ideas. And so basically, like intelligence applied to humanity is like this thing that basically makes everything better. And then we look at the world around us, right, including being able to be in a space like this and with each other, and all the sort of work that goes into creating this kind of environment and everything else that we do. And it's all the result. It's not the we didn't wake up one morning and all these wonderful buildings and electricity and everything was just like sitting here waiting for us as human beings. Like it got built by human beings through the application of intelligence. And so we've built everything we have that we like that makes the world work with intelligence. We've just always been limited by our own capabilities, or our own organic capabilities, and now we have the opportunity to apply machine intelligence to all of these efforts, and basically do an upgrade of everybody's capability to be able to do things in the world. Personally, the part that I find most exciting is I have an 8-year-old, and the thing that's sort of most kind of emotional for me is the idea that every kid from here on out, mine and everybody else's kids from here on out, will grow up with an AI teacher, coach, tutor, mentor, advisor, right, ally, right, that will basically be with him or her for their entire lives, and will be doing everything possible to try to make sure that every person basically reaches their full potential. I rolled out ChatGPT to my 8-year-old about a month ago. Installed on his, put it on his laptop, and I was so proud. Like, this is the most amazing thing I've ever done as a parent for my kid. Like, I feel like I'm bringing like fire down from the mountain, right? It's
like buying a computer
to my offspring, right? It's like I'm bringing him like the most important thing he's ever going to have is like the ability to access this thing, and I loaded it up for him, and I'm like, look, you can ask it a question, and it will answer any question you have, and of course he's like, okay, yeah, like duh, like. What else would you do with a computer, right? Like, obviously, it's going to answer all your questions. And I'm like, no, like, this is really new. Like, this is really exciting. And he's like, okay, Dad. So notwithstanding the fact that he didn't understand the significance of that, I understand the significance of that. And I think kids are going to grow up in a very different and much better world as a result of this.
We were programmers, so we were the punch cards for these kids.
I remember every single step that the computer industry had to take to get to the point where you can like answer any question, and like, yeah, no, for him it's just obvious.
So is this the new computer? I mean, some people have argued this is the von Neumann architecture, memory, CPU instructions, programming with precise semantics. That was the previous computer. We re-implemented in this old computer, this new computer that prompt engineering and knowing how to talk to it and extract the information you need from it. This is a new computer, and that's what people should learn. Do you think that there's some truth to that, or not really?
Yeah. So there's a whole backstory here. So there's this great book called Rise of the Machines, where it goes through the history of AI, which in the early decades, back in the 30s, 40s, 50s, was called cybernetics. And it turns out they actually had John von Neumann actually had there was an argument at that time that he and Alan Turing and all these other guys had, back in even the 1930s, even before they got to the point where they had the electronic computer. And the argument basically was, they knew they were going to build the computer. They knew this thing was going to happen, right? And it was an old idea. You know, Babbage had the difference engine idea, and so there was like a 70 or 80 year period where they were thinking about how to build. You know, they had calculating machines and tabulating machines and these things. So they knew they were going to build general purpose computers, and they knew the technology was getting to the point where they could do that. And they actually had this big argument back then: should the computer be should it be an evolution of basically a calculator, right? So should it be a thing, you know, now known as a von Neumann machine? Should it be a thing that basically executes deterministically, right, sequences of instructions that are literally exactly what the programmer tells it to do, right? Or should you basically not do that at all, and should the computer be based on basically the model of the human brain? And right, they actually knew about neurons. Like, they actually knew quite a bit about neurophysiology at that point. And so like I said, the neural network paper came out in 1943. And there were quite a few people at the time who argued, no, we should skip the von Neumann machine, we should just go straight for the brain. But they didn't, right? They didn't have they didn't have the chips, they didn't have the data, they didn't have like all the underlying technology, so they couldn't do that back then. But it was even obvious back then that there were these two different vectors to build two different kinds of computers. The way I think about it is the computer we've had for the last 80 years, the von Neumann machine, is basically super linear, super deterministic, right? Super like every programmer knows, like if you program a von Neumann machine computer and it makes a mistake, it's always the programmer's fault, right? 100% of the time it's the programmer's fault, which is like, you know, as a programmer you always feel guilty all the time because you're like, you know how many bugs are in your code. This is a new kind of computer. This is I call it neural networks. Basically, they're probabilistic computers, right? And what does that mean? Which is like, you ask it the same question twice, it will give you different answers, right? And so just the basic idea that you have a computer that you ask it the same question twice, it'll give you different answers is like an amazing thing. If you word the question different ways, it will give you different answers, right? You know, if you, I don't know, catch it on a bad day, it will give you different answers. Like if the training data changes a little bit, it will give you different answers. If you stroke it, like if you compliment it, right? And or you tell it to like model its answer after like certain famous people, or you do all these basically these so-called prompt engineering is sort of this form of sorcery. It actually gives you different answers. And then it does this amazing thing, which is it will hallucinate, right? It will literally, like, if it doesn't know the answer, it will make up the answer. And people look at that and they're, you know, sort of the engineering mind, you're kind of horrified by that. But of course, you know, if you have a creative kind of bent, you look at it and you're like, oh my God, the computer's actually making stuff up. Like, we actually have a computer that's like creating fiction, which is like a fairly amazing thing.
It's like us, basically.
Yeah, so basically it's a lot like us. Well, this is my conversation with having, you know, a lot of friends of mine are like, yeah, I don't know whether I can use this thing because I don't know whether the answer's correct. And I'm like, well, have you ever worked with a human being, right? Like, this is what we're like, right? And it's like, yes, if a human being tells you X, Y, Z, it's like, yeah, you might at some point want to double check to make sure that they remembered everything correctly, right? But the reason you talk to other human beings is because other people have ideas that you don't have, and they create ideas that you don't have. And so you know, it's amazing we now have both of these. And of course, what's going to happen is they're going to get integrated. Like you're going to end up basically with hybrid systems. You already have this with ChatGPT. You can, you know, if you just ask ChatGPT math or science questions, it will often get them wrong. But if you use the Wolfram Alpha plugin along with ChatGPT, all of a sudden it starts to get all that stuff right. And so I think a lot of what's going to happen now is sort of a practical form of engineering where you'll bring together both sides, you know, both of these architectures, and you'll have computers that can both create and also, you know, answer, you know, do things literally.
So what does it mean for us? Like, I mean, you know, come on, many of us grew up programming, loving it. I mean, it was the art form that it was our craft. We loved it, right? We can't not do it for, you know, a week of our lives. What does it mean for our profession going forward? Is programming, well, I'm not asking if the jobs are going away. I'm asking if programming as we know it, this very structured, you know, semantically unambiguous way of writing code, right, is that not really going to be a thing in 5-10 years? And, you know, really you're doing this English prompt engineering to, you know, work with a statistical computer, or no, programming will probably be around and we'll still need lots and lots of people who can write very precise code.
Right. So I think what's going to happen is I think most programmer jobs, most of the activity, I think it's going to basically go up a level, right? And so more and more being a programmer is going to be like being a manager of programmers as opposed to writing all the code yourself, right?
Great, we're all managers now.
We're all managers. Well, except of course what you're managing, are you managing the AIs, right? And so you know, the way this is going to happen is you start today, you use something like GitHub Copilot today, and it's like, okay, I'm a programmer, I've got the AI, and it's kind of helping me at suggesting things. You know, it's kind of, you know, fixing bugs for me, and so forth. And then basically what's going to happen is as those systems get more sophisticated, you'll be able, as a programmer, to basically give them like more complex assignments. And you'll be able to say, okay, write this code, write that code, do this, do that, and it'll kind of go off and do it and kind of report back. And I suspect what will happen, and today it's like a pairing. It's like a person with like an AI copilot. I suspect what's going to happen is it's going to be like a person with like more than one of these copilots, right? And so I think you're going to have basically like, maybe you start with 2 and then basically 5 and 10, and then maybe like really skilled programmers are going to have like 1,000 of these AI assistants, right? And then as a consequence of that, you're basically going to be able to oversee effectively an army of AIs, and then it's just a question basically of how much time and attention and effort can you put into kind of overseeing this whole thing. I tend to think the really good programmers are still going to be trained for a long time in the fundamentals of how this stuff actually works. In the same way that really good mathematicians are trained. Really good mathematicians are still trained in.
Is math going away because of calculators?
Right. Exactly. Right. Exactly. Right. And so the really good programmers are still going to understand everything all the way down to the metal. But the really good programmers are going to be much more productive. Right? They're going to be able to do a lot more in their careers than they could do before. And then a lot of people who can't code are going to be able to actually effectively program. Right, and there's been a long-running trend through kind of these kind of low-code, no-code tools to get to the point where ordinary people can write programs without having a computer science degree, and I think that's really going to go on steroids. And so I think a lot of people who are not trained programmers are going to be actually creating code.
Yeah, so that's about programmers. If we like broaden it to the job market as a whole, some people say, hey, there's a fixed set of amount of work that needs to be done, and we have this much labor to do that work, and now we have computers that can do a lot of it. So now there's less work to be done, so there'll be less jobs. Right. What's your thoughts on that?
Yeah, so that's sort of it's a classic fallacy in economics called the lump of labor fallacy that you're alluding to, which is right. It's this zero-sum view of the world where there's a certain amount of work to be done. If machines do the work, then humans don't have anything to do. What ends up happening is actually very much the opposite, which is basically when machines can take over things from people, what you actually do is you free people up to actually do more valuable things, right? And so there was a time when 99% of us were basically farmers, right? And then later in the Industrial Revolution, there was a time when 99% of us worked in factories. And sitting here today, there's a much smaller percentage of people who work on farms and factories, but there are many more jobs in total, right? Because a lot of new demand got created and a lot of new businesses and industries got created. And so I think there's going to be just tremendous economic growth that follows from this, huge amounts of job growth. Wage growth also flows naturally from this. Specifically with code, code has this property where basically the world can never get enough of it. Like there are always more programs to write. There are always more things that you want code to do. Nobody's lacking. Everybody knows. Everybody who's in a business knows this. Like nobody ever runs out of ideas for what they want software to do. What they run out of is the time and the resources to actually build the software that they want. And so I suspect what happens is both a massive increase in basically the amount of software in the world that comes out of this, and then also ultimately a very big increase in the number of people actually working on software.
That's awesome. Okay, so final topic I want to touch on because I think it's like really relevant for this crowd here. We've been saying data and AI is the future. I've been saying that the crowd here. You are the future. You talked about legends and heroes. Can you tell us a little bit about that? And how should they? And actually, some advice maybe to the audience. Where we have young folks that are beginning of their career. They're thinking about they're here. Marc Andreessen. You've been able to see 10, 20 years ahead of time, many times before. How should they think about their careers and what should they get into and what should they get good at looking forward?
Yeah, so in my piece, I use the terms legends and heroes. So the legends I refer to is you literally had people, scientists. This is sort of the science side of things. You had computer scientists, mathematicians starting in the 1940s who basically worked for 80 years without really getting AI scientists without really getting a payoff for their work. And I just remember when I was in college, 89 to 94. And I remember, studying AI at the time for computer science, and AI at that point was like a backwater. It was like a discredited. There had been an AI boom in the 80s that didn't work. Like it was a bubble and a burst, and a bust. And it was very bad at the time. And so by the late 80s, AI had been very discredited, and this had been about the fourth of those cycles where AI basically there was a lot of promise, and then it just didn't work. And so I remember that you had scientists working on AI in computer science departments and in labs. Where they would literally be born, grow up, get their PhDs, become professors, teach AI for 30 years, retire, and have nothing to show for it, right?
And pass away. I mean, they're not even.
And pass away, exactly. A lot of them are not here today, and literally, they were working on a set of ideas that we now know those ideas were going to work, but it took 80 years, and so the level of determination and vision right, and courage and insight and stubbornness like required to like devote your life to a field where you never get the payoff. You know, now that we know that if it never works, you start to wonder if they were, you know, completely sane. Now that we know that it works, you're like, wow, they saw the future. Like they really understood it the whole time. They got it. You know, it just needed time, you know, for the whole thing to pay off. And so I put them in the legends categories. And then look, in the heroes category are all the people who are making it work today.
So it could be all of the crowd here,
which
right?
is the whole crowd here. And I use that word specifically because, and I talk about this in the essay, like we're in this kind of cultural moment where just like people are really mad about like everything. Like people, I don't know if people have noticed, but like a lot of people are in a bad mood these days about like a lot of stuff.
It's been a while.
Yeah, the country and the world is in kind of an emotional funk of some kind. And as a consequence of that, you know, any new thing that happens, immediately the sort of arguments come out for why it's bad and horrible and it's going to destroy the world and it's going to like be like this like horrible, you know, if you just read the newspaper accounts of what's happening, it's just like to be this horrible thing. And so I think anybody actually working to make a better world possible through this technology, which is I think what they're doing, you know, I think it's a hero.
So this is, you know, so basically people working hundreds of years, you can finally reap those benefits. So we're really lucky to be alive right now. And, you know, you can all become the heroes of the future.
Yeah, that's
Marc
right.
Andreessen, thank you so much,
Good.
everyone. Thank you.
Thank you, everybody.
Thanks, Marc.
Awesome. Thank you, man.
Thank you.
Thank you, Marc and Ali, for such a wonderful fireside discussion. Today, we're going to hear from the creators of these incredible projects that you see listed up on the slide here. We're going to kick it off with the data projects, starting with Apache Spark. What started as a research project at UC Berkeley, Apache Spark has become the de facto big data processing framework out there. I love the collaboration across industry, academia, and open source to truly embrace and contribute to this project. For our next speaker, we're going to have the co-founder and chief architect of Databricks, who still manages to find the time to be one of the top overall contributors to Apache Spark, to tell us about the latest and greatest in Apache Spark, Reynold Shin. Please join me in welcoming Reynold to the stage.